All right, let's look at planes. We're going to try to come up with the standard equation of the plane, right? So let's derive the equation. All right, so in order to identify a plane, we need to know which way the plane is facing and at least one point that the plane goes through. All right, let's just say the point it goes through is x1 comma y1 comma z1, and it's facing in the direction of this is called a normal vector. Maybe I should write that. This is a normal vector, a comma b comma c. Right. So we're going to try to create a vector. So I'm going to pick a random point. So any point on the arbitrary point on the plane, x comma y comma z. So this is sitting on this plane P. Right. So what we want to do is we want to come up with the equation that satisfies every single point on that plane. Right. So we picked a random point x comma y comma z on this plane, and I'm going to create a vector from the given point, which is x1 comma y1 comma z1, to this random point, the x comma y comma z. Right, so let's look at this vector. Right, so this vector is going to have components. So it's going to be x minus x1 and y minus y1 and the z minus z1. Right, so what's special about these points on the plane would be any vector. So the vector created going from the given point to an arbitrary point on that plane is going to be always perpendicular to this normal vector, right? So let's take the dot product. Remember, if they are perpendicular, then the dot product their dot product will be 0, right? So here's the normal vector. So you have a comma b comma c, and we're going to take the dot product with this vector, x minus x1 comma y minus y1 comma z minus z1. Right, so this dot product is equal to 0. Right, then we have this equation. Right, so we have a times x minus x1 plus b times y minus y1 plus c times z minus z1, and that's the dot product, and we have to set that equal to 0. All right, so this is actually, I like this equation better than the standard form. All right, but this is basically the equation of the plane. But to get to the standard equation, we just have to multiply out so that it looks a little bit simpler. So what you do is distribute the a to both terms, and we end up getting ax minus ax1, and you do the same way with the second term. We're going to have plus by minus by1, and we distribute c to z and a negative z1. We get cz minus cz1. That's equal to 0. Right? Then what you want to do is, since you have a bunch of constants, so you have a constant here, this is a constant here, and this is just a constant. We can just send all these guys over to the other side, right? Then we end up getting this. All right, what's left is ax and plus by plus cz, And all these three terms used to be negative. They're all positive now. So you have ax1 plus by1 plus cz1. And we just decide to call that guy D. So we're going to call this guy D. Then we have this standard equation. So this is a standard equation of the plane, which is ax plus by plus cz is equal to D. All right. All right. Let's look at an example. Say you have a plane whose equation is 3x plus 2y plus 4z is equal to 12. Let's find the its x-intercept. So to find the x-intercept, what you need to do is we want to set y and also z equals 0. Right? So you can see that the second term and the third term will be 0. So what you get is going to be 3x is equal to 12. So we can simply divide through by 3 to isolate x. So x-intercept is 4. Right? And y-intercept, if you're looking for y-intercept, we set the other two guy, x and z, equal to 0. Right? Then what you get is, let's see, so it's the first term and third term are 0. So you're just going to get that 2y is equal to 12. And then we can just divide through by 2 to get y equals 6. All right, and the z-intercept is we're going to set the x and y equal to 0. So we get simply first term and the second term is 0. So you have a 4z is equal to 12. So we have divide through by 4. We get the z to be 3. Right? So we got all three intercepts. And we can do trace too. As you remember, if you want to do xy trace, so xy plane equation is z equals 0, right? So you're going to get 3x plus 2y is equal to 12, right? If you want the yz trace, we set x equals 0. So you're going to get 2y plus 4z is equal to 12, right? And if you want the xz trace, so we set the y equals 0, right? So you have 3x plus 4z is equal to 12, right? All right, so let's sketch the graph of this plane. All right, since we know the bunch of intercepts, so let's put those things in there. So you have x-intercept is 4, so I would just say 1, 2, 3, 4. So we're going to have a point, so we have to go through there, right? And y-intercept is 6, so it's going to be 1, 2, 3, 4, 5, 6. Right, so the point is going to be there, right? And then z-intercept is 3, so it's going to go up 1, 2, 3. So we have 3, and we have that. Right? Then if you look at the, say, xy trace, the equation of xy trace, so here, this will be the trace. Let's see, what color should I use? Maybe I'm going to use green or something here. So this is going to be the xy trace. right, of the plane. And YZ trace is right here. So here's the YZ trace. Right, hopefully I can hit there. And then this is the XZ trace. It looks kind of like this. It's going to be a three set of three straight lines, right? Then it's kind of hard to draw, but the plane itself is going to be a plane that looks kind of, so we have to draw an edge. There's no edge on the plane, but you know, to be able to see it, so I'm going to just try to draw a plane, maybe looking kind of like that. All right, so this is going to be the plane that we're looking at. All right. Then you can see that the normal vector, so normal vector for this is, if you find that, is normal vector of this plane is, right, 3, 2, 4, right? So if you sketch the normal vector, so it's going to look kind of like this. Maybe I'll just use, so here's, let's see, x is 3, so it's going to go through there, and y is 2, so it's going to go through there, and then 4, so it's going to be up here, so 4. So it's a 3, 2, 4. So if you sketch a vector, so you're going to have to do, maybe we can just draw a box here, right? So we have something like that, and draw like that. So here we draw a box here too, right? So we have that, so it's going to go up, right? And then it's going to look like that. Right, then so we're going to use that as the head of the arrow, and it's kind of hard to see, but this is I'm going to put the tail at the origin, and then here is the vector, you can see, right? So you can see that that vector is perpendicular to the plane given here, right? That's it. I hope that this was clear.